Example, say LED or light emitting diode is there. So we have an LED or a light emitting diode. And example that is emitting out a wavelength of 670 nanometer. That's a wavelength which is emitted out by the LED or a light emitting diode. And the power of the LED, like let's say we have an LED, the power of this LED is how much? That is example 50 milliwatt. So 15 to 10 power minus 3 watts. If I want, what is the energy of the photon? A single photon, or I need how many photons, because this is a power. I need energy of one photon and I want how many photons it will emit out every second. So if I need the energy of the energy of the photon will be same as the energy of the electromagnetic radiation. So what is the energy of the electromagnetic radiation? We can use a formula E is equals to HF, or we can also use a formula E is equals to Hc over lambda, where H is a Planck's constant, C is the speed of a electromagnetic radiation, which is 3 exponent 8, and lambda is a wavelength. So if I need E, what is a Planck constant? It is a fixed value that will be given in exam. You don't have to memorize, but it is 6.63 into 10 power minus 34. That's the energy of Planck's constant. C is the speed of the light, which or electromagnetic radiation, 3 exponent 8 divided by the wavelength, which is 670 nanometer. Nano means 10 power negative 9. So 6 into 10 power minus 9. What's the answer when we divide? You can annotate on the screen. 6.63 exponent minus 34 times 3 exponent 8 divided by the wavelength, 670 exponent minus 9. What's the energy of this photon? That is 2.7997. 2.7. 2.97 exponent minus 19. Okay. Okay, 2.97 exponent minus 19 joules. That is the energy of this photon. The equivalent photon which is emitted out. And then how we can work out how many photons are emitting out. If I need the number of photons every second or rate of the photon. So the power of the source divided by energy of one photon. So power of the source was how much? It was 15 to 10 power minus 3. And energy of a one photon was 2.97 into 10 power minus 19. So when we divide this, we got 1.68 into 10 power 17 photons per second. So this many photons will be emitted out every second to have this power. So if you need a number of the photons coming out every second, it's the power of the source divided by energy of photon. You will know how many photons will come out every second. Is it clear about the energy of a photon as well as number of photons per second? Anyone having a doubt or a question till this point? Then the unit of energy, normally the unit of energy is joules, but we can also use the electron volt as a unit of energy. Yeah, P is a momentum. Lambda is equal to H over P is refers to a momentum. So what is the unit of energy? Like unit of energy is joules, but we can also use the other unit, that is a electron volt. Normally we use for the particles. So we have electron volt is one unit and joule is another unit. And one electron volt is equivalent to what? It is equivalent to 1.6 into 10 power minus 19 joules. But when you substitute your values in these formulas, like example, E is equals to HF or E is equals to Hc over lambda. So this energy should always be in joules. So normally the question, they will give you energy in electron volts, so you don't forget to convert energy into joules. And what is the relation between the kinetic energy and the momentum of the particle?